Over 4 million tons of hydrogen peroxide is produced annually, and almost half is used in chemical manufacturing. However, current routes to peroxide production are costly, energy-intensive, and atom-inefficient. For decades, scientists have been trying to develop a catalyst that creates and utilizes hydrogen peroxide in situ. Catalyst deactivation, poor selectivity, and low yields have prevented widespread adoption. A team of scientists has recently overcome these challenges with a focus on the production of cyclohexanone oxime, a key intermediate of nylon. They have developed a new one-pot process using catalysts consisting of gold-palladium alloys immobilized onto a titanosilicate support. In this process, hydrogen peroxide is first generated and then reacted with ammonia to form hydroxylamine. The hydroxylamine then reacts with cyclohexanone to make cyclohexanone oxime. This process rivals state-of-the-art industrial technology and significantly lowers production costs and environmental impact. By optimizing the catalyst at the nanoscale, the team has demonstrated a process with real-world feasibility. The next step is to develop the technology to the industrial level. This technology isn't restricted to nylon production and demonstrates that through academic and industrial collaboration, significant advances can be achieved, paving the way for a cleaner, more efficient chemical synthesis sector.